Bismillah ar-Rahman ar-Rahim. Assalamu alaikum everybody. I'm going to record our lecture, and inshallah that this will be very helpful for all of you to hear the record over and over until you get the points. And then when we meet during our class, you guys can prepare questions for me, which we can inshallah communicate either via written messages, voice maybe, because the load all over the internet will be less, and or even WhatsApp at that time. So I'm going to record this regarding our chapter 4. Okay, so I will start from the beginning, because last time during the lecture many students were not able to connect with us. This is chapter 4. I am opening the book pages as we are used to. That first of all we start with screening the chapter. What is it talking about? And if you see here also the main picture of the chapter, that because always the main picture of the chapter, it gives us the brief idea what is this chapter about. If you can see that there is a space shuttle and it's launched with so many gases at the back of the shuttle, which you can see that pink arrow going down, and the shuttle movement is up, and we see here kind of forces that we will talk about later. But this could remind you that, or it could refresh your memory of what we are gonna talk about. Hopefully that some of you will now, they will answer that it is kind of, it reminds you with Newton's laws of motion, and this is one of them. And if you go deeper in your memory, it could also tell you that it is the third law of motion, which is action and reaction. For now, I will not go in more details, but this is just a brief idea about the picture that is in front of us. Now, as we expect, the chapter is talking about Newton's laws of motion. There are 3 laws of motion, 3 Newton's laws of motion. First, second, and third. And if you see here the sections of the chapter, which, as I mentioned before, they are 8 sections, and they are all included in our syllabus. All of them, from 1 to 8, nothing will be cancelled. And if you see that it's mentioned in section 4.2, it's Newton's first law of motion. Then in the 4th section, Newton's second law, and in the 5th, it's Newton's third law. I want to mention something here, and it's very important. Order makes very big difference in Newton's laws. Like, if you say first law, it is the first law. If you second law, this is different than the first law. So it's not you are counting 1, 2, 3. The first law has its own definition, its own concept. The second law is completely different than the first law, and the third law is way different from all of them, both of them. Now, of course, they are related with each other, but I mean to say, for example, if anybody will recall, what is Newton's second law of motion? What is Newton's second law of motion? If I will ask anybody what is the most famous law of motion, it is F is equal ma. If you recall, it is F is equal ma, and that is second law of motion, Newton's second law of motion. So you cannot call this Newton's first law of motion. Now, in Newton's third law of motion, which comes here, this is the action and reaction. So Newton's third law is action and reaction. You cannot say it's F is equal ma. I hope that the idea is clear for you, that second is F is equal ma, third is action and reaction, and we will come in details for each one of them. But for now, I want to emphasize on what is the second law, what is the third law, and then now let's start with Newton's first law of motion. Newton's first law of motion is interesting. It's called the law of inertia. It's called the law of inertia. I will go through again that these kind of things, with you here. Okay, but for now I am just introducing. I'm introducing for the chapter. But later on in the chapter, you will see here that Newton's first law of motion is called the law of inertia. And what is the meaning of the law of inertia? I would like to translate this word in Arabic just for anybody who have studied in Arabic, that this could bring something in their memory. What is the law of inertia? The meaning in Arabic is قانون القصور الذاتي. قانون القصور الذاتي. From the word قصور and from the word ذاتي, the literal translation for قصور, it's the shortage, and الذاتي, self shortage. Basically that the object on its own has no power to change its own status, except if an external force will act on it. It means if I have a box and I kept it over the table for years, the box will not be able to move itself unless you apply an external force on that box, which will let it move. So, if the object is at rest, it will stay at rest unless an external force is acting on it. All right. What about the moving object? The moving object will also be moving in the same velocity, in the same direction, unless other force act on it. So, if I have an object which is moving with a velocity half meter per second to the right, conceptually it will keep moving. What is the number I've said? Half meter per second to the right forever, unless some external force act on it, which will change either the speed or the direction. But somebody can, so let me frame the other part of the law of inertia. The first part was that the object at rest will stay at rest. And now the second part, the object which is moving will stay moving with the same speed and direction unless an external force acting on that object. All right, so the one at rest will stay at rest. The one which is moving with the same velocity, it will keep moving with that velocity unless an external force act on it. Now, somebody could ask me that what about if a tissue box, imagine that I am throwing the tissue box on the floor of the classroom and I just push it away and then eventually it will stop. But it's very clear for all of us that I gave it the first push and I pushed that tissue box and it stopped, even though nobody else acted with any external force over that tissue box. Then why did it stop? Why the velocity came to zero? Yes, there is an external force act on it, which is the force of friction. You got it? So if this is an external force which slowed down the box till it reached to zero. Otherwise, if I push the box on a frictionless surface, it will keep moving forever. In brief, It took us around less than 10 minutes, but this is the first law of motion. I will skip this section for a minute. This is the Newton's first law of motion, and here he is basically mentioning, of course, the force of friction, because this is the thing that we cannot avoid in real life. But here also he is explaining more about Newton's first of motion, and also he said that, of course, he's mentioning what it is, that every object continues in its state of rest or of uniform velocity. So you see, this is more nicely written words if you really want to like put it in a beautiful wording. In a straight line, as long as no net force acts on it. Okay. I like that the book here said no net force acts on it, because forces could be acting on it, but the net force is zero. So that is considered as if no force is acting on it. But it's more accurate to say no net force acts on it. I like this better. This is more accurate. You will come back to this word net once we explain the forces acting on the object. So this is the best explanation for Newton's first law of motion. You see, this is the Newton's first law of motion. Of course, as I always advise you, that when you go for screening for your chapter, it's always important to see if there is a figure, read what is underneath the figure. If you cannot still figure it out, read the paragraph which is talking about that figure. That will give you better understanding. Same thing, if the book is highlighting something, go and read it. That will be important. Now here it says the tendency of an object to maintain its state of rest or uniform velocity. So now we keep in mind those two new words, state of rest or uniform velocity. State of rest or state of uniform velocity in a straight line is called inertia. So the object itself cannot change itself, whether it's at rest or at uniform velocity, and that is called qusur, inertia. Now you understand the meaning of qusur. The object cannot. He will maintain his state of motion or of rest. And that is why Newton's first law is called law of inertia. Now, a very interesting example is explained here. And you see, there's a conceptual example. But if you understand this example, I think you're done with first law of motion. Let's read it together, or let me read it for you. A school bus comes to a sudden stop, and all of the backpacks on the floor start to slide forward. I think this is something that we have all seen in our life, either in a school bus or in a normal car, or maybe in any moving thing. If it has a sudden stop, the things which were like backpacks, and maybe when you were traveling with the bus and then he come to a stop, if you are not holding on your bag, it will slide forward. So what force causes them to do that? For the backpacks to slide forward? Is there any force? No, there is no force. But the answer is in Newton's law of motion, first law of motion. I will leave this example to you because this first recording will end in a few seconds, and I want you to understand it. It's very well explained in the book, and if you still didn't understand it, you can ask me later. Thank you, and see me in part 2.